Hi guys, a very good evening everyone. Welcome to Om Institute, and yes guys, the Genco exam date has been announced. 14th of July is going to be finally the exam conducted for the TS Genco. And yes, so here on at Om Institute platform, now let us bring you some important sessions, practice sessions, as well as we'll bring you revision sessions as well. Okay, so every sort of support will be there by the entire team of Om Institute for all the aspirants, okay, who have prepared for Genco. And but still, this last 20-30 days are very important, because the practice and the revision you do in this last 20-30 days is actually going to really boost up your rank by a lot of numbers. Okay, so that's what, very, very good evening everyone. Quickly keep on joining. For all the aspirants, okay, who have prepared for Genco, and but still, this last 20-30 days are very... Yes. No, Ashok, I don't stay permanently in Hyderabad, but I keep coming. I'm coming to Hyderabad once again next week also. Alright, so very good evening everyone. Quickly confirm me the audio video if everything is good at your end. No, Ashok, I don't stay permanently in Hyderabad, but I keep... Yes guys, I think the audio looks good, but still in case of any issue, you can also just let me know if there is anything, any issue with the audio video by chance at your end. Yes guys, all very good evening, Rajendra, good evening, Ashok, good evening, Sham. Yes, all okay? Okay, it's all okay. Hal Kumar, very good evening. So I haven't any specific hours that I have kept, Ganesh, but yeah, definitely will practice enough number of questions, enough number of important questions for your Genco examination. Okay, covering different aspects of control system. So today's control system, and similarly, multiple other subjects you will be getting. Okay. One side as in Arvind, can you please clarify? One side means, of course, only my audio can be audible to you. You cannot speak in this particular session. That is absolutely okay. Yes guys, so okay. Sure. We'll plan more classes. Okay, so let's get started. This is the first one, and definitely we'll plan. I'm telling you, me and other faculties also will plan all other classes also for you. Not only practice, but some revision, theory revision classes also will be planned for you. Okay, just stay updated. All other theory revision classes will be planned for you as well. Okay, so I think if audio and all is good to you, let's get moving ahead. Okay, let's get moving ahead. Okay, so I think you might have seen by this time, this is a brief intro about me in case somebody new to my sessions. Okay, so this is Rakesh, secured 9th rank in GATE examination, completed masters from Indian Institute of Science, Bangalore, and these are the subjects that I'm dealing for many years now. Okay, so we are here to have the revision and practice session on control system. Also guys, for all of you, okay, there is a free TS Genco live online test series that is going to be conducted for all the aspirants of Gen free of course. Already a huge response has come up to this. Okay, so there are going to be 2 full mock tests, okay, full mock 1 and full mock 2. Okay, one is on the coming Sunday, June 23rd, and then the next would be on June 7th. Okay, and all these tests will be active at 1 p.m. and you can clearly, scan here for free registration. Okay, if you interested, just scan this, open the QR scanner of your mobile, or you can also contact 9515694053 for any further details, or visit our website www.ominstitute.com. Also guys, for the Telangana AE examinations, the new offline batch, those who want to prepare for upcoming AE examinations, June 24th is going to be the new offline batch, okay, for all of you guys. Okay. Also for AP Transpo and AP Discoms, okay, another new offline batch again starts from 24th of June. So for any more details regarding to these batches, you can contact 9515694043 or again visit our website. Okay. Sure, Arun, there will be many more classes for Genco. Don't worry, there will be many more classes for Genco. Here it is guys, first question. Okay, all the questions relevant to the level of Genco, and with every question, let's revise, some important points and important concepts here. Okay, good evening Arun, good evening Karthik. Okay, everybody keep joining and keep sharing the session to all your friends whoever are preparing for this Genco examination. Here it is, guys. Okay. Chalo, the open loop gain of a unity feedback system is given to you, omega n square upon s plus 2 omega n. The unit step response of the system would be of which form? Which of the option will be correct here? Okay, so, of course, omega n is not given, but if you see here, okay, zeta is definitely given. Now, maybe you can remember standard GS, or more commonly, students remember the characteristic equation, and it is wise to remember characteristic equation only. So, if I go for the characteristic equation, it's unity feedback. What will be my characteristic equation, dear? In general, the characteristic equation for any control system is given by 1 plus GSHS equal to 0, where GSHS is known as the open loop gain, right? Okay, very good evening, Venki. GSHS is known as the open loop gain. So 1 plus GSHS, GS is given to you. Okay, and of course, the HS is 1 because it is mentioned as unity feedback. So solving which, I will be writing it as S square plus 2 omega ns plus omega n square. And when you compare with the standard equation, okay, this particular term, S square plus 2 zeta omega ns plus omega n square, rest everything is in same place. Okay, so by comparing the standard form, okay, what is the value of zeta I would have is zeta equal to 1, and for zeta equal to 1 the system has what type of response? The response of the system is non-oscillatory and critically damped. For zeta equal to 1 and greater than 1, for both the case it is non-oscillatory, and zeta equal to 1 represents critically where the system reaches equilibrium as quickly as possible. Correct answer is D. Okay, the type of response is B, corresponds to zeta equal to 0. This is undamped. Okay, this is again, this is also negatively damped. So A and C are for negative zeta. Okay, A and C are for negative zeta. This is for zeta less than -1. I will mention for your revision. Okay, option number C will be the case when zeta less than -1. Okay, when zeta is between -1 to 0, negative, but between -1 to 0, the type of response you obtain is A. B is for zeta corresponding to 0, undamped case. And for zeta between 0 to 1, underdamped case. Correct, G? Okay, so correct answer as of now for this question is option number D. Okay, corresponding to critically damped, zeta equal to 1. Okay, let's be ready for the next question here. The two unity feedback systems A and B with the open loop transfer functions are given, GA and GB. There are two open loop transfer functions again. Okay, again the two systems are unity feedback. Okay, and for both open loop transfer functions are given, GA and GB. Which of the following statement is correct? So it's about comparing overshoot which has higher, lower, or which has lower or higher settling time or equal settling time. So it is comparison of two parameters, overshoot and settling time. Okay, let us revise the important points here, dear. Okay, so for previous question, many of you came up with the answer like Durga Prasad, Ashok, Arvind, Rajendra, you came up with D. Okay. Yes, Arun, like today to Thursday, same time 6 p.m. you will have the practice session for signal and system. You will have practice session for signal and system, and very soon I will take a revision session also for signal and system, a revision complete marathon for signal and system. Okay, that will also be there for you very soon. Okay, just stay updated and wait for it. Right? Done. Which of the following statement is correct? Come on, let's check. Okay, so GA and GB. See, what is the first and second characteristic equation? Okay, for the first system, if I write down the characteristic equation, dear, that is going to be 1 plus again GSHS. So 1 plus 9 upon S plus 1 equal to 0. This will correspond to S square plus S plus 9 equal to 0. Okay, whereas the second one, characteristic equation, if I say, okay, it is 1 plus 16 divided by S plus 2 equal to 0. So that corresponds to S square plus 2S plus 16 equal to 0. Okay, right. No, Arvind, it is not possible from my end. Okay, one headset is working, so there may be some system settings as you have to check. Okay, there isn't something that I can do from here. My voice is either coming or not coming. I don't think it has to do anything with headset being one side or two side. Check the settings of your headset or your system maybe. Okay, Durga Prasad, Arvind, please do check it up. So Ashok says answer here. Chalo, come on guys, let's check it out. Okay, so dear, okay, for this one, what is the value of omega n square? This is omega n square. For the first system is 9. Omega n equal to 3. Okay, omega n is equal to 3. Okay, and for the second one, similarly, omega n square is 16. So omega n equal to 4. What about the zetas? Okay, what about the zeta? Chalo, let us check the zeta here. So 2 zeta into omega n. What is omega n? 3. This is 2 zeta omega n, which is 1. So zeta is 1 by 6. For the second case, what is happening? For the second case, correct. 2 zeta into omega n is 4 is equal to 2 and zeta is 1 by 4. Zeta is 1 by 4. Correct. Okay, Lal Kumar also comes up with the answer A. So, dekho, now if I compare both, okay, for the first one, zeta is 1 by 6, omega n is 3. And for the second one, zeta is 1 by 4, correct? And omega n is 4. Omega n equal to 4. Now, overshoot. Okay, what is the relation of overshoot with zeta that you should know? Okay, what is the relation of overshoot or zeta that you should know? If I write down the overshoot formula, it is given by e power minus pi cot phi into 100 if I write on percentage, or this is also written as e power minus pi zeta upon under root 1 minus zeta square into 100. Now dear, okay, you should not use the formula to calculate overshoot, but you should remember, okay, that with increasing zeta, this overshoot decreases. Okay, if zeta is higher, overshoot is lower. Okay, overshoot is lower. Okay, so now for which of the system zeta is higher? Okay, definitely 1 by 4 is higher than 1 by 6. Zeta 2 is greater than zeta 1, and hence I can say that the overshoot for the second system will be lesser than that of the first system. Overshoot for the second one will be less than that of the first system. Okay, okay, so second ka less, first is having higher overshoot. So A has higher overshoot, option number A correct. Definitely then other should not be correct, but still let us check. What about the settling time? Now dear, what is the settling time formula? Okay, what is the settling time formula? Okay, settling time is given by 4 by zeta omega n for underdamped system. Both of the systems are underdamped. Okay, both of the systems are underdamped. So settling time is zeta, which is equal to 4 by settling time is 4 by zeta omega n for underdamped. Okay, for underdamped system, correct? Okay, so now for the first one, what is the settling time? Okay, do I need to calculate, or let us only compare zeta into omega n? For the first one, zeta omega n, 1 by 6 into 3 will be 1 by 2. Okay, okay, and for the second one, what is the zeta omega n? For the second one, what is the zeta omega n? 1 by 4 into 1 will be equal to 1. This is actually critically damped. Oh, sorry. Zeta omega n is 1, sorry, zeta is not 1, zeta omega n is 1. Okay, so if you are able to see the second zeta omega n is higher, the second settling time will be lower. Okay, so whose settling time is higher? First zeta omega n is low, so settling time for the first one will be higher than that of the second one. Okay, zeta omega n is in denominator, na? Wherever zeta omega n is lower, the settling time will be higher. Okay, so A has higher, the first system has higher settling time, not lower, and they don't have equal. So that is why C and D are wrong answer. C and D are the wrong answer. Everybody okay with this calculation? Okay. Yes, Prabhavati also says answer A. Correct. Answer number A. Answer number A. Okay. Anyways, this is MCQ questions only in Genco, so any one option correct. So we got A correct, but still I have cross-verified the settling time also. Clear everybody? Settling time 4 by zeta omega n for underdamped, and both are underdamped because zeta is less than 1 for any zeta between 0 to 1. Okay, for any zeta between 0 to 1. This is the settling time formula. Correct. Next question, dear. A second order system with a 0 at -2 has its poles at -3 plus J4, -3 minus J4 in the S plane. The undamped natural frequency and the damping factor of the system respectively are. Okay, undamped natural frequency and the damping factor of the system are, sorry guys, this is not damping factor, this has to be damping ratio. Please correct this question. It has to be damping ratio. It has to be the damping ratio. Okay, so let's check it out. It has to be the damping ratio. So chalo. Now see, second order poles. What is the story about the second order poles? The poles are in general given by the formula minus alpha plus minus j omega d, or it is minus zeta omega n plus minus j omega n under root 1 minus zeta square. Okay, so we know that zeta is the damping ratio, omega n is the natural undamped frequency. Okay, undamped natural frequency omega n, damping ratio is zeta. Okay, this term alpha, which is zeta into omega n, is known as the damping factor, is a damping factor, and this omega d is the damped frequency of oscillation. Damped frequency of oscillation. Hi, good evening, Aruna. So Pratyusha says answer is D. Let's check it out. Okay, so now very simple comparison you can have. Okay, what is the poles given to you is -3 plus or minus J4. Okay, that means alpha, which is product of zeta and omega n, is 3, and the omega d, which is omega n under root 1 minus zeta square, is given to you as 4. Two equations and two variables. Okay, you can find two variables, you can find both the values, but you can do something even more easily. What you can do something even more easily? Okay, dekho, zeta into omega n, the product has to be 3. Okay, the product has to be 3, and there is only option number D which satisfies it. Getting it? Yes, correct, Anil Kumar, correct, Ashok, D is the correct answer. There is only one option which satisfies this, and that is option number D. Okay, this product, have a look into it. Zeta into omega n equal to 3, only satisfied by D. That is where you have to take the advantage of the MCQ questions. Correct, Himanshu, correct, Lal Kumar. No, Lal Kumar and Ashok said B. No, just check it out. It is D only. Himanshu correct, Anil Kumar correct. Okay, it is option number D. 5 into 0.6 will be 3. Okay, so only option number D satisfies, and hence no need to check the exact value of zeta and omega n, although you can find, but not required actually. Okay, actually not required. Hope this approach is clear to you. Next one. Consider the open loop transfer function 5s plus 1 upon s square, s plus 5, s plus 12. Okay, correct, Ashok Kumar, now correct answer. Yes. The open loop transfer function is given to you, the steady state error due to unit parabolic input. Okay, so see, what is the type of the system? Okay, what is the type of the system? Okay, s square, of course it should be unity feedback. Okay, so let's consider unity feedback, and 5s plus 1 upon s square, s plus 5, s plus 12. Okay, this corresponds to type 2. Okay, this corresponds to type 2 because of s square, the number of poles of GS at origin. The number of poles of GS at origin for unity feedback system. So it is type 2. Okay, and whenever system is type 2, dear, what are the standard results for type 2? Whether it is type 0, type 1, type 2, all standard results must be known to you. Okay, whenever it is type 2, dear, what is the steady state error? Okay, for step input, if the question was step input, 0. Okay, what is the steady state error for ramp input? Again 0. What is the steady state error for parabolic input? That is non-zero finite value, and that is given by 1 upon Ka, where Ka is known as the acceleration error coefficient. Ka is known as the acceleration error coefficient. Now what is the value of Ka? Ka is given by the formula. Ka is given by the formula limit of s tending to 0 s square gs. Okay, for unity feedback. Okay, of course take hs equal to 1, unity feedback. Okay, let us assume the unity feedback. Okay, so Ka is given by limit of s tending to 0 s square gs. So this is equal to limit s tending to 0 s square into gs. I will place the value of gs, 5s plus 1 divided by s square, s plus 5, s plus 12. Okay, so s square cancel. Now put s tending to 0. So this is 5 into 1 upon 5 into 12, to 1 by 12. So what is the steady state error? Reciprocal of this, and reciprocal of this will be equal to 12. Answer is C. Reciprocal of this is equal to the 12. Answer is C. Okay, so yes, correct answer. Himanshu, Ashok, Lal Kumar, Pratyusha, Anil Kumar, Monica, Sushma, Hari. Okay, so all being interactive. Yes, guys, be interactive and keep solving. That's what. Okay, it is almost your end game, your end stage of preparation going on, and yes, this is really the time where you should be active in solving enough number of questions, undoubtedly. Just a second. Yeah, correct. So let's move ahead to the next question. A unity feedback system. Okay, what is the value given to you? Okay, GS is K s plus 2 upon S plus 4 S plus 9. What is the value of K to yield 10% error in the steady state? Of course, now let me specify some more things in the question, which is even more obvious. See, what is the type of the system given to you? This time it is type 1, S power 1. Okay, this time what is given to you is a type 1 system because of s power 1, number of poles of GS at origin. The number of poles of GS at origin. It is type 1. Okay, and because it is type 1, dear, what is the steady state error for step? 0. What is the steady state error for ramp? This is finite, 1 upon kV, where kV is the velocity error coefficient. And what is the steady state for parabolic? This turns out to be, for type 1 system, it turns out to be infinite. So of course there is a 10% error, finite error given in steady state. Okay, so this has to be, this has to be due to unit ramp. This has to be due to unit ramp input. Of course, it has to be due to unit ramp input. Otherwise, the answer would be either 0 or infinity. Okay, it will only give a finite error for only unit ramp input, otherwise not. Finite non-zero error. So of course, we'll take it as unit ramp input. Okay, so now, the error is 10%. The steady state error is 10%. Okay, or that is 0.1. Okay, and steady state error, as I mentioned, is 1 upon kV is 0.1 and hence kV has to be 10. Further, again, what is kV? kV is given by limit of s tending to 0, s into gs. Correct, guys? Limit of s tending to 0, s into gs. Limit of s tending to 0, s into gs. That is the value of the kV. Okay, so that is given by limit of s tending to 0, s into gs. Okay, s into gs. Okay, what is the gs given to me? K s plus 2 divided by s plus 4, s plus 9. Okay, so s cancelled and this becomes k, then s tending to 2, so into 2, 4 and 9. Overall it is turning out to be k by 18. Overall it is turning out to be k by 18 and this is 0.1. Okay, so if I solve this separately here, see what is given to me. Steady state error is 0.1 and that is 1 upon kV. That is 1 upon kV and 1 upon kV will be 18. Sorry, so already I have written, let us directly use kV. Sorry, already I have written this calculation. kV is 10, okay, and kV is k by 18. So what is k? 180. What is the value of k? 180. Correct answer is option number B. Correct answer option number B. Yes, the yes correct answer Himanshu, Pratyusha, Hari, Lal Kumar, Ashok, Prabhavati, Mohan. All right. Option number B is the correct one. B is the very correct answer. Let's get moving ahead to the next question. Let us get moving ahead to the next question. Here it is. Which one of the following statements is correct for the open loop transfer function? Which one of the following statement is correct for the open loop transfer function? Gs equal to ks plus 3 upon s minus 1 for k greater than 1. Okay, k is given to be greater than 1. Okay, open loop system stable, closed loop system unstable. So options are checking what? Open loop stable or closed loop stable? Yeah, both stable, both unstable. What is the story here? What is the story here? Okay, so already the open loop transfer function is given to you. Okay, gs. Of course, hs is 1. If the open loop transfer function is only gs, so hs is 1. Okay, now, what is that open loop transfer function? K s plus 3 upon s minus 1. Okay, and what are the poles of, what are the open loop poles? Okay, dear, what is this term? You should always remember OLP. I call it as open loop poles. What are open loop poles? Poles of open loop transfer functions. What are the poles of open loop transfer function? The poles of open loop transfer function are 0 and 1. Okay, that is just obtained by this denominator. Okay, and very clearly one of the open loop pole is in RHP. So for any function, for any transfer function, if there is a pole in RHP, that represents unstable transfer function. So definitely open loop unstable. Definitely open loop is unstable. Okay, now what about closed loop? So write down the closed loop transfer function or write down the characteristic equation, any one of them. Okay, now let us come to the closed loop analysis. Okay, ji. Let us come to the closed loop analysis. So what is the characteristic equation? For the closed loop analysis, what is the characteristic equation? Okay, write down the transfer function or characteristic equation, anything is fine. So 1 plus GSHS equal to 0 again. So 1 plus K s plus 3 upon s minus 1 equal to 0. So s square minus s plus ks plus 3k equal to 0. That means if I just rearrange the terms, I have s square, okay, plus k minus 1s plus 3k equal to 0. s square plus k minus 1 s plus 3k equal to 0. Now, it is a second order case. It is a second order characteristic equation. Think, do we need to go to Routh-Hurwitz? Do we need to go for Routh-Hurwitz, or can we say something directly? Just a moment. Do we need to go to Routh-Hurwitz? Come on, tell me. Just a moment. Yeah, let's come back. Yeah, so do we need to go for Routh-Hurwitz? No. Yes, very good, guys. We don't need Routh-Hurwitz. Of course, if it was higher order, third or fourth, we can go for Routh-Hurwitz. Even for third order cubic, we have shortcuts, but for generally higher order, we need the Routh-Hurwitz. Here, only coefficient signs are important. For second order system, if all coefficients of characteristic equation are of same sign, then the system is stable. No need for Routh-Hurwitz. Now, what is the sign of k minus 1? Okay, dekho, given k greater than 1. Okay, given k greater than 1, so this factor k minus 1 is definitely positive. Okay, this factor k minus 1 is definitely positive. Okay, so this coefficient 1. Okay, k minus 1 also positive. Now k greater than 1 means k is positive, na? So 3k is also positive. All coefficients are of same sign. All coefficients are of same sign, and it is second order, so the system is stable. Because it is second order, no RH required. Okay, and hence the system closed loop is stable, open loop unstable. Answer is B. Okay, the answer to be marked is option number B. Correct? The answer to be marked and highlighted here is the option number B. Chalo, cool. Next, let's go to the next one. Let us go to the next one. Here it is. For the characteristic equation of a control system is given to you. Which of the following is the symmetric root pair of the system? Symmetric, one of the symmetric root pair of the system. Imaginary, symmetric, and that too pure imaginary roots. Okay, now all of these options are pure imaginary in nature. How are we going to approach this question? Okay, the characteristic equation, which is fourth order, of course you can't solve fourth order. Even if you use calculator, you can't solve fourth order. Na? Okay, the options are given to you as pure imaginary. Okay, so this is pure imaginary. Okay, pair they are talking about. Okay, and pure imaginary roots of characteristic equation will only come, okay, due to the presence of auxiliary equation. Okay, this will only come due to the presence of auxiliary equation, and auxiliary equation can only come whenever the Routh array has row of zeros. Whenever the Routh array has ROZ. What is ROZ is known as row full of zeros. Okay, and auxiliary, this is what is auxiliary equation. Correct? This is what is auxiliary equation. This is what is the auxiliary equation. Chalo. Okay, so some answers have started coming up. Himanshu and Hari says it is C. Let's check it out. Okay, now a row of zeros can be seen in the RH, so let's form the RH corresponding to it. The Routh-Hurwitz, start with two rows of s power 4 and s power 3, the highest one being s power 4 here. Alternate coefficients, so 1 and 6 and 8 will come up in the first row. 1, 6, 8, and then s cube. Okay, so alternate terms 2 and 8. This alternate terms 2 and 8, and next is not there, so 0 I will write. Now next s square row, we know how to form the Routh array, reverse cross multiply, so 2, 6, 12 minus 8. Okay, that will be 4. 4 divided by 2, okay, will be 2. Okay, now again similarly, first column always remain the same, change the next column of the matrix. So 2 into 8 minus 0, that is simply 2 into 8, divide by 2 again, so this is 8. Okay, so two rows are exactly identical, and that is why when you solve for the next row, okay, when you solve for the next row, okay, yes, that is what, the row of 0 will definitely be coming, Rajiv. Okay, so when you solve for the next row, see, 2 into 8 minus 2 into 8, definitely 0. This is complete 0, okay, the entire column is 0, so when you solve, okay, 2 into 0 minus 2 into 0, 100% 0. Last element of a row is always 0. last element of a row is always 0, and this is what I am telling you. Okay, this is what I am telling you. This is what, this is what I am calling it as row of zeros, correct? This is what is this row of zeros for me. Okay, now whenever there is row of 0, whenever there is a row of 0, we will form the auxiliary equation. Auxiliary equation is formed by the row above the row of zeros. Okay, auxiliary equation is formed from the row which is above the row of 0. Okay, so that leads to the which equation? That is the equation which is in second term, s square, quadratic. Okay, with the coefficient 2, and then this should be alternate coefficient, so 8 s power 0. If this is s square, next term will be s power 0. So simply 2s square plus 8 equal to 0, or even if I cancel 2, s square plus 4 equal to 0, s square will be minus 4 and s will be plus minus j2. Okay, this will be the imaginary pair. Okay, plus minus j2, answer is C. But let us continue. Let us do some more analysis here. Answer is option number C anyways. Okay. So yes, correct answers. You know, some of you have given C, like Himanshu, Hari, Durga, Lal Kumar, Mohan, Vinela, Anil, Ashok. Correct. Answer is option number C. Okay, but now generally when we want to talk about stability analysis, now we continue, we complete the Routh array. So next what we write down? Next what we write down is the modified s power 1 row. Now how do you write down the modified s power 1 row? How do you write down the modified s power 1 row? Okay, by taking the derivative of this auxiliary equation. Okay, now when you take the derivative of this auxiliary equation, it becomes 4s equal to 0. It becomes the 4s equal to 0. Okay, so what is the s power 1 row? What is the coefficient of s power 1? 4. Okay, and then 0, 0, no other coefficient. And then last row s power 0. When you are forming s power 0, which are the two rows you will use? S power 1, the new modified s power 1, and the s power 2, of course. Okay, so this is 4 into 8 minus 0. 4 into 8 divided by 4, it's going to be 8 here. Okay, the entire column 0, the answer is 0. Last element anyway 0, this is s power 0. Okay. So if I have to do the complete analysis, okay, how many RHP roots, how many LHP roots, and etc. How many RHP and LHP? Let's quickly revise that also. Anyways, answer is option number C. Okay, plus minus J2. But how many RHP and how many LHP roots? How many RHP and how many LHP roots? So see dear, okay, there is no sign change in the first column. Okay, now when I look into the first column, there is no sign change. That means there is no RHP root. Okay, even now if I look into the first column, okay, there is no sign change. Okay, so how many RHP roots? Okay, 0. Okay, then how many LHP? Okay, how many LHP? Okay, for that we know the j omega axis roots also. So by this auxiliary equation we have got that there are two roots on the j omega axis, plus minus j2. There is a complex conjugate pair here. Okay, so how many on the j omega axis 2? So how many are left for LHP? There are total 4 roots. Why? Because it is a fourth order equation. Out of the 4, how many goes to RHP? How many goes to j omega? 0 on RHP, 2 on the j omega. So how many LHP? 2. What is the comment on the stability? What is the comment on the stability of the system? Okay. If there is even one RHP root, the system will be unstable. But there are no RHP. Still system is not stable. Still system is not stable. Okay, system is not stable because it has a pair on j omega axis, which makes it marginally stable. For it to be purely stable, now all roots are in LHP. If there is a pair on imaginary axis, that makes it marginally stable, or even if a single RHP root, then the system is unstable. That is what we know. Okay, the system is marginally stable. Okay, now we know that marginally stable system is having oscillatory response. Whenever a system is marginally stable, the response is oscillatory. It keeps on oscillating. Okay, and whenever there is an oscillatory response, it will have a frequency and time period. Okay, what is the frequency of that oscillation? What is the frequency of that oscillation? What is the frequency of that oscillation? So dear, you have got that S equal to plus minus j omega. This plus minus j2 corresponds to plus minus j omega n. Okay. The location of the roots on imaginary axis also tells you the frequency of oscillation, because sometimes they can ask you, Okay, if the system is oscillatory, what is the frequency of oscillation? So that frequency of oscillation here is equal to 2. Okay, that frequency of oscillation here is equal to 2, corresponding to S equal to plus minus J2. Those are the roots of auxiliary equation. This is obtained by roots of auxiliary equation. Okay, these are obtained by the roots of auxiliary equation. Clear? Acha. Also, please take a note. Be very careful. Also, please take a note that suppose, okay, here you got how many RHP 0, how many on j omega 2, how many on LHP 2, and I called the system as marginally stable. Okay, but suppose the scenario was something of this kind. There was one sign change. Okay, so how many RHP 1, j omega 2, so how many will be left on the LHP is 1. Rest everything remains same, but let us assume another situation where you got one RHP root. Okay, now if you had got one RHP root, then what will I say? If you have got one RHP root, then and still two j omega roots, still there is a pair of imaginary roots. Will the system be still oscillatory? Will the system be still marginally stable? No. Even if a single RHP root, system is clearly unstable. Okay, so please don't talk about any frequency of oscillation here. Frequency of oscillation is associated with the oscillatory system, and for the system to oscillate, okay, it has to be oscillatory or marginally stable. Okay, or for that you should have a single pair on the j omega roots, okay, with nothing in the RHP. If there is one RHP, it is unstable. The response is negatively damped. Okay, the output will keep on not only oscillate but will keep on increasing. Okay, and it will become unbounded after a certain point of time. After a certain point of time. Okay, so that is how it is going to be. That is how it is going to be. Okay. Even you can follow this shortcut for this auxiliary equation. There is one more way, dear. What you can do is, okay, now suppose I have the auxiliary equation and I have the characteristic equation. Okay, what is the order of both? Okay, what is the order of both? See, always remember one shortcut. Okay, do you need to solve this auxiliary equation every time? What are the roots of auxiliary equation? Do you need to solve this every time? Not required. Do you need to solve this every time? No, not required actually to solve it every time. Here it was solvable, and here I needed to solve because I needed to find the roots. Okay, they were asking about that imaginary roots only, that complex pair, that imaginary pair. Okay, but if I only want to comment how many LHP, how many RHP or how many j omega roots, not necessary to solve auxiliary equation. Okay, what you can do is, okay, just write down the order of the auxiliary equation. Here it is second order, see na, auxiliary equation, second order. Okay, and overall characteristic equation, fourth order. Overall characteristic equation, fourth order. Okay, now the shortcut is, okay, now the shortcut is, what is the shortcut for auxiliary equation? The shortcut for auxiliary equation is that always for any auxiliary equation, because it is only equation which is containing even powers, so number of LHP roots, let me write down RHP roots first, number of RHP roots is equal to number of LHP roots, okay, is equal to number of sign changes. Number of RHP roots is equal to number of LHP roots is equal to number of sign changes, okay, below the auxiliary equation. Okay, below the auxiliary equation. For any auxiliary equation roots, the roots are symmetric, the number of LHP, RHP roots are equal. Okay, and then how many RHP roots actually? The RHP roots are the roots below, the RHP roots are the roots which are represented by the number of sign changes in the first column. Okay, but that is below the auxiliary equation. Number of sign changes in the first column below the auxiliary equation, because I am focusing only on the number of RHP roots of auxiliary equation. So where is my auxiliary equation? Here. See, where is my auxiliary equation? Here. Okay, it starts with S square term. So what are the sign changes below this? I don't have to bother about this because I am only interested in the roots of this auxiliary equation, which starts with the S square term, which starts with the quadratic. So 2s square plus 8 equal to 0. How many sign changes below it here? 0. Okay, so how many sign changes here? 0. So how many RHP roots and how many LHP roots? They are always equal and both of them are 0 here. Both of them are 0. That is why how many j omega? So the auxiliary equation order is 2. 0 in the RHP, 0 in the LHP. That means nothing in the R, nothing in the left. So that is why both the roots are on the j omega. Now coming to the characteristic equation, how many RHP roots? Coming to the characteristic equation, how many RHP roots? How many RHP roots? So for that again you have to see the number of sign changes in the entire first column. Number of sign changes in the entire first column. See how many RHP roots is always by the number of sign changes in first column. If you want the overall characteristic equation RHP roots, the overall sign change. If you want to know the number of RHP roots only for auxiliary equation, okay, so just look below this part. Just look into this part only, from where the auxiliary equation started. Okay, chalo. Okay, so that is what it is. Okay, so here, how many RHP roots? Even if I see overall, there is no RHP roots. How many j omega? That is always decided by auxiliary equation part. So this says 2. So how many LHP? That is 4 minus 0 plus 2. Okay, that is 2. Okay, so here we don't need to solve. Here you don't need to solve the auxiliary equation. Okay, the shortcut for auxiliary equation is number of RHP roots and number of LHP roots will be equal. Actually, let me tell you one more important point. With this question, let us revise some important points. So let me tell you one more important point. What is that important point? Okay, so whenever there is row of 0, whenever there is a row of 0 coming, okay, in any characteristic equation when you are solving through the Routh-Hurwitz, okay, and whenever there is a row of 0 coming, okay, there is definitely the following possibilities of the roots. Following possibilities of roots. There are three following possibilities of roots. Okay, there are three following possibilities of the roots. I will tell you all three. Okay, number one scenario, okay, when the roots are pure imaginary, that is seen in the previous question. Number two, okay, roots are real, okay, of the form, okay, plus x minus x. Okay, equal magnitude but opposite sign. Okay, this is of the form plus jy, this is of the form plus jy minus jy. Okay, roots are complex conjugate lying on the imaginary axis, that is pure imaginary pair. This is plus minus x. Next possibility is a quadrature, okay, of the form x plus jy, so there is x minus jy. There is also minus x plus jy, and there is minus x minus jy. Okay, all the roots are always symmetric with respect to origin. Okay, plus y minus y below. Okay, minus x plus x left, equal distance right. Okay, and even if you calculate the distance of all of these four with respect to origin will be same, under root x square plus y square. Okay, the roots are, okay, the roots are symmetric. Okay, whenever there is a row of 0, the roots, okay, of auxiliary equation are symmetric with respect to origin. Okay, symmetric with respect to origin. The roots are symmetric with respect to origin. And that is why I told you number of LHP and number of RHP roots for auxiliary equation are always same. Okay, like here both of them are 0. Here both of them are 1 each. Number of RHP and LHP 1 each. Here number of LHP and RHP are both 2 each. Are both 2 each. Okay, Rajiv will bring you the HPCL. Let the date also be clearly coming up from HPCL. Then we'll bring that also. Okay, guys, fine. Let's get moving ahead. Let us get moving ahead. Chalo. Just a second. Okay, fine. Next question. The characteristic polynomial of a feedback control system is given to you, SQ plus KS square plus 9S plus 18. When the system is marginally stable, what is the frequency of sustained oscillation? Okay, now this is cubic. This time you are given a cubic characteristic equation. The cubic characteristic equation. Okay, what is the shortcut for cubic characteristic equation? Dear, what is the shortcut for cubic characteristic equation? See, when you have the characteristic equation of the format AS cube plus BS square plus CS plus D, again cubic makes an important and repeated question, so you should also know it directly. Okay, In around 2 to 3 months, exact cannot be said, but around 2 to 3 months, somewhere this much time will be there, Ashok. Okay, so ASQ plus BS square plus CS plus D. Okay, now what is the condition for the system to be marginally stable? See, when I'm telling shortcut, it is actually coming from RH only. See, it is actually coming from RH only. It is a simple one. Okay, A and C, alternate coefficients A and C, and B and D here. Okay, then S power 1. Okay, so you will write BC minus AD divide by B, last element 0, S power 0, X into D by X, so you'll be left with D. Okay, now A, B, D, of course I'm assuming all coefficients are positive, that is the necessary condition. Of course A, B, C, D is positive. What else has to be positive for stability? Okay, BC minus AD must be positive for stability. Okay, because if this is positive, all coefficients are of same sign, no sign change, no RHP root. Okay, this is what will be required for stability. Okay, that is what BC minus AD, inner terms and outer terms. Okay, so okay, when BC greater than AD, okay, system is stable. Okay, when BC is equal to AD, when BC is equal to AD, system will become marginally stable. System will become marginally stable. And of course the other one, see, when BC equal to AD, okay, you will have this term 0, row of 0. Okay, row of 0. Okay, marginally stable condition will come. And when BC is less than AD, sign change will come. Sign change means RHP roots will come and system is unstable. Okay, BC and AD. So this product BC and AD will matter here. We call it as product of inner terms or product of means. A into D, product of outer terms or product of extremes. Okay. Yes, definitely another session is coming up for signal system also, where in next one, Anil, definitely. Okay. So this is BC and this one is AD. Chalo, cool. So let's move ahead to the next. Let's move ahead to the next. Okay, this is BC and this one is the AD. Chalo, let's move ahead. Okay, so for this question, what is the condition? Okay, when the system is marginally stable, okay, so we need BC equal to AD. Okay, BC equal to AD. What is BC here? 9 into K. And what is AD here? AD here is 1 into 18. Is 1 into 18, that is 18. So for K equal to 2, system is marginally stable. But I don't want the value of K, I want the frequency of oscillation. Marginally stable means system is oscillatory. Marginally stable. So what is the condition for that marginally stable? Okay, so BC is equal to AD. Now what is the auxiliary equation? What is the auxiliary equation? See, how to write down the auxiliary equation by the shortcut first. How to write it by the shortcut. So dekhna yahan pe please. Okay, marginally stable system leads to oscillatory system. That is correct. And oscillatory system means it will have some auxiliary equation. Auxiliary equation is always an equation with even, it's an even polynomial. It starts from s square or s power 4 like that. Here s power 4 is not possible. So it will start with s square only. So it will be bs square, and then every auxiliary equation can contain only even powers. So s square and then d, s power 0. This is the constant term d, s power 0. So for a marginally stable system, how do you write down the auxiliary equation? See, one way is you write down the Routh-Hurwitz, but without the Routh-Hurwitz, be logical. Auxiliary equation always starts in an even polynomial, s square or s power 4 or etc. Okay, so here s square is possible. So what is the coefficient of s square? Bs square. And then only alternate terms are coming up here. So plus d equal to 0. Okay, so what is that auxiliary equation here? What is that auxiliary equation here, dear? Ks square plus alternate term 18 equal to 0. What is the value of k? I wanted k here. So k is 2 now. So 2s square plus 18 is 0. S square will be 9 or minus 9, and s equal to plus minus j3. And that is what plus minus j omega n. So what is that frequency of oscillation? Answer is D. It is equal to 3. What is the frequency of oscillation? Correct answer is D. Very good. Yes, guys. The very correct answer is option number D. The very correct answer is option number D. Okay. Yes. We'll bring aptitude sessions also for gate, also for Genco also. Don't worry. We'll bring it for both. Okay. It is equal to D. Okay, let's move ahead to the next. Let's move ahead to the next question. A unity feedback system shown in the figure 1. Okay, the root locus of its characteristic equation is shown in the figure 2. Okay, if P minus 5 comma 0 is a point on the root locus, okay, then the variable parameter k of the system at the point P. Okay, what is the variable parameter k at the point P? Okay, when P is a point on the root locus, every point lying on the root locus must satisfy the characteristic equation, and root locus is given to you. Okay, so very simple. From the root locus, what you can do? Okay, from the root locus, what you can do? Okay, number one, you can find out the characteristic equation and satisfy P, or other way around. What is the other way around? Okay, there are two ways of finding the value of k. Okay, there are two ways of finding the value of k. Listen to me. What is the value of k? Okay, method number one. Okay, every point lying on the root locus should satisfy the characteristic equation. So can you find out the characteristic equation of the system from here? Can you find out the characteristic equation of the system from here? Okay, for characteristic equation, definitely I need GSHS. Okay, I need the GSHS. So can we find the GSHS from here? Please see. And then I will tell you the method number 2, which is even more straightforward. Just allow me a minute, dear. Just allow me a minute. Okay. Yes. So that is what. Can we find the characteristic equation? For that I need the GSHS. Okay. So what is that method number 1? Okay. Method number 1 is, okay, every point lying on root locus, every point which is lying on the root locus must satisfy the characteristic equation. Okay. That is 1 plus GSHS equal to 0. 1 plus GSHS equal to 0, or we can also solve by the magnitude condition. Mod GSHS equal to 1. GSHS equal to minus 1, so you can also find by the magnitude. Okay, right. So mod GSHS equal to 1. Mod GSHS equal to 1, and GSHS here can be found easily. Okay, because this is what, this is a 0 given to you, and there are two poles of the system given to you. This is the 0, this is a pole, this is a pole. So what is the GSHS here? What is the GSHS here? Okay, what is the GSHS here? Okay, so it will be equal to some k into the 0. 0 is at minus 3. So I will write down s plus 3 in the numerator. And poles are at minus 2 and minus 1. So denominator I will write s plus 1, s plus 3. Okay, so mod GSHS equal to 1. Yeah, directly 1 plus GSHS equal to 0. Satisfy the point P here. Okay, what is the point P? Minus 5 comma 0. Okay, so s is equal to minus 5. Please satisfy. S equal to minus 5, because that is what is the point P. Okay, so put s equal to minus 5 and 1 plus GSHS should be 0. That is one way. Second way, now you can complete the calculation. Second way, simple, direct, I will tell you. Okay, second method. K, okay, by the product formula, it is obtained by this only, mod GSHS equal to 1, or 1 plus GSHS equal to 0. It is obtained by this only. Okay, and, sorry, that is s plus 2, typo error, this is 2. The 0 was at 3. Okay, now listen to me. The next method is k is also given by what? It is given by the product of distances of the point P. Okay, I am talking about at some point P. Okay, the product of distances of the point P from what? From all the poles divided by, this is a direct method, especially when the pole 0 diagram is known to you. Product of distances of the point P from all the zeros. From all the zeros. Correct. Product of distances of the point P from all the poles divided by product of distances of the point P from all the zeros. Correct, everybody? This is what is there. Okay. So if I have to follow this, then what is the value of k? If I have to follow this. Okay. So this is the point P. Okay, product of distance with respect to all the poles. So minus 5 and minus 2, distance is 3. Okay, see, note down, this distance is 3. Distance with respect to other pole, that one will be equal to 4. And distance with respect to 0, minus 5 to minus 3, distance is 2. Okay, so 3 into 4, okay, Product of distances from pole, product of distances from 0, there is only one 0 and distance is 2. Okay, and hence this answer has to be 6. Everybody okay? The answer has to be 6. Okay, so if you know that second technique, you can directly tick mark here. Okay, just look into the geometry. Okay, this is my point. Okay, distance from pole 3, distance from another pole 4, so 3 into 4. Now, denominator, distance with 0, 2, so divide by 2. That's it. Very simple. It becomes an observation question then. Okay. Yeah, definitely. Many questions are straight questions, memory based or theoretical or simple numericals. Okay. Like this also, provided your practice is always good. So this also is a question which can be solved within 1 minute, easily within 1 minute. Okay, so up to this level. So whatever is the level expected that we are discussing, of course, few questions, not all, but very few questions can be good also. Be ready for that. Very few questions can be good also. Okay. Okay, good means not tough, but at least better than that. At least something better than this. That is also possibility. Okay, dear. Chalo. Next one. Let's move ahead to the next one. Okay. The root locus for a system is given below. The open loop transfer function corresponding to this plot is given by what? The open loop transfer function corresponding to this plot is given by what? Tell me. The open loop transfer function is given by what? GSHS. Ks s plus 1 upon s plus 2 s plus 3. Ks plus 1 upon s plus 2 s plus 3 whole square, etc. So this is only a basic analysis of the poles and zeros. Okay, with a simple twist in the question. Okay, with a simple twist in the question. Have a look into this. Okay, let me highlight the poles and zeros more clearly. Maybe it's not that visible. -3 represents pole location, -2 represents pole location, -1 is a zero location, and this origin is a pole location. I have highlighted it more clearly. Now please see what can be the possible answer. Now just see what can be the possible answer. So see dear, okay, definitely, okay, the answer will have to be containing a 0 term, and that is 0 at -1, so factor is s plus 1. Then there is a pole, then there is a s square term. Okay, then there is a s square term. Okay, sorry, not s square, s, there is a pole at origin. Then there is a pole at -2, there has to be a s plus 2 term. There has to be a pole at -3, so there has to be a s plus 3 term. But when you look into the root locus, dear, okay, when you look into the root locus, see, is this the correct answer? See, when you look into the root locus, see the arrows. Okay, root locus exists on both the sides. Root locus is existing on both the sides of this particular pole. Okay, what is the odd number criteria? Okay, what is that odd number criteria of root locus? Something you must know. What is the odd number criteria of the root locus? As per the odd number criteria, okay, root locus will exist, okay, on the section of real axis. Root locus will exist on the section of real axis where, okay, the forward poles and zeros, okay, I in short call it as FPZ, is an odd number. FPZ, forward poles and zeros. Poles and zeros when you see to the right, forward. Okay, so now please see here. Look into this one. When I see the forward poles and zeros here, on this section, when I see the forward poles and zeros, how many? I have one pole. One is an odd number? Yes, so root locus is defined here. See, that is why there is a root locus between 0 and -1. If I see the forward poles and zeros here, there is no poles and zeros, 0, nil, and that is counted in even number. Okay, that is why there is no particular root lying here. That is why there is no particular root locus branch lying here. Similarly, there is no root locus, there is no bold line, there is no arrow here, because when I see to the right, how many poles and zeros? There are 2. 2 is an even number. Okay, 2 is an even number. So root locus cannot exist on the real axis here. Between -2 and -3, see, there is a root locus given. Okay, starting from -3 and -2, then there is a breakaway condition coming up, etc. Okay, so dear, okay, how many poles and zeros here? 1, 2, 3. 3 is an odd number. That is why root locus is defined here. Then, when I see the forward poles and zeros from here, 1, 2, 3, 4. When I see the forward poles and zeros here, how many? These are 4. When I see the forward poles and zeros here, these are equal to 4 in number. These are equal to 4 in number. Then what is the answer? Okay, then 4 is an even number. Root locus should not exist here, but root locus is still existing here. That means what? Root locus is still existing here. That means what? It looks like a simple question. You can say answer is D, but it is not D. Okay, because here also root locus existing and it cannot exist for even number. Okay, that simply means that this also must be an odd number, and this simply means that at -3 there has to be a double pole. At -3 there has to be a double pole. Okay, 2 poles at the same location, so that 1, 2, 3, 4, 5, this becomes an odd number, and hence our expression should have s plus 3 whole square term. S plus 3 whole square term, answer is B. Okay, s plus 3 whole square, and the correct answer is option number B. The very correct answer is option number B. Done eh? Okay, the very correct answer is option number B. Okay, so sometimes there can be small twist, and you should be ready for it, of course, handling those small twists and etc. Okay, now first take up this question. The transfer function of two compensators are given below. Okay, the transfer functions of two compensators are given below. 10 s plus 1 upon s plus 10 and s plus 10 upon 10 s plus 1. Which of the statement is correct? Which is lead, which is lag? Very simple analysis. Which is lead, which is lag? Okay, the transfer function in which there is zero dominance is a lead compensator. The transfer function in which there is a pole dominance is a lag compensator. So for the C1, what is the pole and zero? For the C1, what is the pole and zero? Okay, let me write down the 0 here. -1. And what about the pole? -10. What about the pole? -10. So which is dominant? Okay, which is dominant? 0 is dominant, means which is the dominant term, which is closer to the origin. Okay, which is closer to the origin. So this is known as 0 dominant. And hence this one will be a lead compensator. Now coming to C2. Okay, coming to the C2. What is the 0 term? S plus 10 equal to 0, so S is -10. And what is the pole term? S plus 1 is 0, so S equal to -1. Here, which is dominant? Here the pole is closer to the origin. 0 is away, pole is closer, so this is pole dominant. Very simple way identifying lead and lag. This one is having pole dominance and this one is a lag compensator. This one is a lag compensator. Pole dominance and hence a lag compensator. Is a lag compensator. Okay, so lead and lag. Okay, this is lead and lag. Lead and lag. Okay, so option number A. First is lead, second one is lag. Option number A. C1 is lead, C2 is lag. Correct, everyone? C1 is the lead, C2 is the lag compensator. Done eh? Very good. Moving ahead to the next. C1 is a lead, C2 is a lag compensator. Chalo. Let's move ahead to the next question then. Okay. Now a lead compensator is given to you. 1 plus 0.12s upon 1 plus 0.04s can provide a maximum phase shift. Okay, again if you relate the pole and 0, of course it is going to be 0 dominant. No need to check, they have mentioned it is a lead compensator. Now we can also write down the transfer function of a lead compensator in the standard format as 1 plus st upon 1 plus s alpha t. Okay, the standard way of writing this is also known as 1 plus st upon 1 plus s alpha t. Okay, where the 0 is known as 1 by t, minus 1 by t, and pole is known as at minus 1 by alpha t. The pole will be known as at minus 1 by alpha t. Okay, so this is what is the pole and 0. This is what is the pole and 0. Done? Chalo. Let's check this. Okay, so now if you compare this 1 plus 0.12s upon 1 plus 0.04s, so when you compare, you get the value of t. Okay, the time constant is 0.12. Okay, and the alpha t is 0.04. What is the value of alpha? The alpha into t, 0.12 is 0.04, and alpha hence is 1 by 3. 4 by 12 it will come, alpha is 1 by 3. Now it will provide maximum phase shift of what? Okay, it will provide maximum phase shift. See, how is the graph actually? How is the phase graph corresponding to the lead compensator? Corresponding to the lead compensator, the phase graph, okay, is approximately of this nature. Okay, it increases up to a certain point and then starts decreasing. The frequency at which it provides the maximum possible phase is known as omega m. Okay, and the value of the maximum phase lead provided to improve the phase margin of the system is known as the phi m. Okay, is known as the phi m. Right? Okay, so what is the value of the phi m? Okay, it is given that phi m, and I'll write down both the formula actually. Okay, omega m. Omega m is given by the formula 1 upon t root alpha, and phi m is given by the formula sine inverse of 1 minus alpha divided by 1 plus alpha. Sine inverse of 1 minus alpha divided by 1 plus alpha. Okay, so here our question is asking the maximum phase shift. So how much it is going to be? Here it is going to be sine inverse of 1 minus alpha. Alpha was 1/3, right? So 1 minus 1 by 3 upon 1 plus 1 by 3, and this turns out to be how much? Sine inverse 2 by 3 upon 4 by 3, 2 by 4, half. Okay, sine inverse half is 30 degrees. Okay, 30 degrees. The correct answer is option number D. The very correct answer is option number D, that is 30 degree. 1 minus alpha divided by 1 plus alpha. Okay, dear. All right. So now, dear, there is something that I need to tell you. Okay, so it's almost more than 1 hour, but yet I have to touch the very important questions from Bode plots, Nyquist plots, and state space analysis. They ask the questions from state space analysis also. Okay, so what I'm thinking is, for control system, let us have another practice session, because in hurry I don't want to complete this Nyquist Bode. Okay, we planned it to be around 1.5 hour session, but even if I take few more minutes, it will not be justice to Nyquist, Bode, and state space analysis. Okay, so guys, is this idea okay? Let us conduct one more control system. Let us continue control system part number 2, where we'll touch the questions of Nyquist and Bode, especially Nyquist, Bode, very important. Gain margin, phase margin, very important. At least let us touch those part, and then we'll take the other subject. Okay, everybody? Is that idea okay? Just come on, everybody, tell me. Rather than doing, those important topics in hurry. So better we will take Nyquist, Bode, gain margin, phase margin, and important questions of state space also. Come on, waiting for your comments quickly. Yeah, that is what. Any exam, these are unpredictable. See, anyways, Nyquist, Bode is 100% important. Nyquist, Bode, gain margin, phase margin. Okay, 100% important. Okay, but state space analysis also they ask. Okay, they can ask. Okay, so yeah, so let's create another practice session, part 2. Okay, so control system part 2. Control systems questions part 2. Okay, same time, alternate. Thursday I will bring at 6 p.m. Okay, Thursday I will bring at 6 p.m. Same time. Okay, Thursday alternate I will bring at 6 p.m. Okay, and then as per your request, okay, signal and system and even aptitude, that is there in the buffer, don't worry. That will also be coming up. Even other subjects by other faculties will also be coming up, don't worry. Okay, so Thursday at 6 p.m. that is going to come up. No, this one more session is there, Saritha. It is there. Thursday means I told you. Okay, Thursday, that not to forget, this is there, and other than that, signals, okay, and other sessions will also be there. Yeah, signals will be there, don't worry. I'll take signals for Genco. Okay, I'll take question session of signals, I'll take revision also. Right, signals will also be there. Okay, so part 2, where we'll have the questions from Bode plot, Nyquist plots, gain margin, phase margin, state space, all this will have it. All right, okay, so better, to take it peacefully. So today we have, because with every question we are also revising some important points, just not like question answer, but you might have seen that we are also revising some important points. Okay, we are also revising some important points. Okay, So that is the reason we are going like this. Also guys, whatever we discuss, listen to me, whatever we discuss in the class, your focus should be taking the question and solving you peacefully. If you don't get it, then see, follow my solution. But whatever I discuss, important points I'm writing, whatever the detailed solution I'm giving, everything in the PDF format will be shared in my Telegram group. Okay, everything in the PDF format will be shared in my Telegram group. Okay, but all those PDFs are password protected. Okay, all those PDFs are password protected. The simple reason is you watch a session, you are learning, you need the notes. Okay, why somebody who is not following the class, they need the note? There is no reason they need the notes. Okay, so you are learning, you are following the class and you need the notes, and that is why you have the password. Okay, you have the password. Okay, so let's create a random password for today. Okay, the password for today's PDF will be face. It's a randomly created password. Okay, so everything in small, PHASE. PHASE. You get my PDF, password protected, and there is a simple logic behind that. Okay, I again repeat. Okay, please don't keep asking the password in the Telegram and all. Okay, because it is only shared for the students watching the class. Okay, where do you get the PDF? Okay, in case if you are not in my Telegram, I have shared you the link of the Telegram. I have shared you the link of the Telegram. You can you can be connected in my Telegram. Just check whether you have received the Telegram link. Just check if you have received the Telegram link. Okay, I think I'll share it once again. I have shared it from the official OM ID. Then I think now it should be there for you. Just check it out now. Yes, now it should be available to you. Please check it out, dear. Okay, so thanks for watching this session, but the next important session is coming up, part number 2, Thursday 6 p.m. I'll share you the link in the Telegram, the session link in the Telegram. Okay, dear. Alright dear, fine, that's it. Now again, at the end, some important updates. As I told you in the beginning also, the TS Genco free online test series for all of you, for all the Genco aspirants. Okay, the OM Institute brings to you the free online test series, where the first full mock test will be on June 23rd, that is the coming Sunday, and second full mock test will be on July 7th, that is the next Sunday. All these tests will be active at 1 p.m. Okay, and you can register for free. Even the test is free. You can appear for free. For registration, you just have to scan this code, open the QR scanner of your mobile, scan the code, and you can register immediately. All right, dears. Okay, so next offline regular batch for GATE 25 starts from June 26. Okay, the fees, which is 66,000, currently priced at 56,000. So all your friends or you planning to prepare for GATE 25, you can inform them. 50% discount for IIT and NIT students, 50% off if you have already studied with OM once, and 30% for triple ITs and state government students. Okay. Now for Telangana AE examinations, new offline batch starts from June 24th. So if you're planning for Telangana AE examinations, and especially for this AP, Transco and AP Discoms, okay, if you're preparing for these AP examinations, the new offline batch is again on June 24th. For any queries about these batches, you can contact 95156 94053, okay, or visit our website www.ominstitute.com. Okay. Also guys, if you want to study online, the next online batch, live online batch, okay, for GATE 25 and 26 starts on, okay, date is not mentioned, I'll just confirm the date, sorry, yeah. Okay, so there will be very soon a next online live batch, okay, whose fees for GATE 25 is 19,999, and for GATE 26 it is 28,999. That are the current prices. Okay, so please take the advantage of the current prices. Okay, it is applicable for both EC and EE, and you can watch these live classes anywhere from our app or from our website, that is ominstitute.com. Okay, again you can contact this number for any doubts or any queries you have regarding to the live online batches. Okay, or there is in the online platform there is also the facility to go for pre-recorded lectures. So this is live lectures where you interact with faculty one-to-one. Okay, and this is recorded when you want to watch the lecture anytime at your convenience, maybe late night, early morning, wherever you feel like. Okay, so learn from anywhere, every time. Okay, you can learn. Okay, the fees of is 30,999, and that is for 18 months, and for 24 months validity, the fees will be 34,999. Okay, this is for gate 25, 26 both. If you especially want the product, you can just go to our website and contact these numbers for any of these products like recorded lectures or live classes or etc. Okay, thank you. Stay connected with me in Telegram for any other updates about my sessions, and the PDF of this session I will share you in the Telegram. Okay, I hope you have received the Telegram link. Okay guys, bye bye. See you on Thursday. Don't forget the time, 6 p.m.